We have a BMS and we would like to test it. Now, testing a BMS could be quite complicated because BMS has so many functions. But let's suppose we just want to test the overcharge where it should cut off and of course the balancing. So we want to make sure that this Chinese BMS does what it's supposed to do. So the first thing we need to do is make sure we have some cat litter ready to throw batteries that explode because we are going to overcharge this. So the reason we need all of the exits is to be able to test and charge each and every one of the cells separately. And in order to check balance, we need first to charge the BMS almost to the limit. Should the first one that goes over voltage should light the LED of its going over voltage. So now remember, you are working with live cells, no adornment, no watches, no nothing. In addition, you have a bucket of cat litter at hand if anything explodes. And in order to charge the batteries, we will need some appliances. So first one, this laptop charger gives us 19 volts, and the reason we need it is to be able, through a buck converter, to charge the mock battery to any voltage level we seek fitting. Notice I added this capacitor 1000 microfarad to stabilize the exit because I am going to charge through the BMS. So this is important. Second thing, we will need to be able to charge singular cells. So this is only a 5 volt charger, also through this buck converter, and at the exit I can charge using the balance wires every certain cell that I want to charge. So I can make one cell imbalance and see if the light goes red here. If it does, it means that the balancing works about this specific cell. We need to do it 3 times. So the question is, what do we do after we charge and how do we go back? So for that we have this 20 watts 10 ohm resistor. It's ideal for this charge the entire pack. It will do it fast. So we can also discharge and then try another cell. This is very important. Before we switch it on, notice the voltage given by the source, including the buck converter, is still too high. We need to correctly tune it to around the voltage that the batteries give, which is currently about 10.8 volt, so a little lower. Okay. Now notice how am I connecting. One of the multimeter is an ampermeter currently. The other one is the voltmeter. The charger goes through the BMS and charges the entire mock battery. We need to connect it like this. Good. So now hardly any current. So we need to change it up to about 1 amp. It should be enough. 2 amps if we insist. But for that we need an heatsink over here and a fan, which I have. It's from above my head. That's enough. Now we charge, and our end aim is to get the batteries charged to around 12.6 volt. Okay, let's give some time. It will not be too much time because I've selected small cells for this mock-up battery. So okay, we'd like to let it do it a little faster, so I increase the current and we'll let it rise. I'm going to do a time lapse here. It will not be too long. Right. So we've passed a milestone. As you can see, we've passed the voltage of the charge to full charge. And indeed, the first battery has gotten above what it's supposed to charge to, and it started balancing. Now, technically, we could discharge now and try to see if another battery balances out, but to save time, we can simply go on charging until another battery passes. See, just now. So we have two batteries we know that are balanced, and now the third one tries to get into the action as well. However, when it will be balanced as well, all of the lights will simply go out because they are already balanced, the three batteries. So now what we need to do is simply discharge and see that indeed we can make each and every one of the batteries charge until it's balancing its own. If we go on with the charging at around 12.8, this will turn into cutoff, and we want to test this too. But before we do that, let's discharge a little bit and see that each and every one of the cells can balance on its own. So let's do it now. Notice that when I disconnect the charger, the voltage drops a little bit, and we are again below the balancing stage. So this is good for us. Now I will try to see if I can balance each and every one of the cells by charging individual cells. This means I will not be using this PC charger anymore, but I will use a 5-volt charger with its own DC to DC. So let's reconnect now. Okay, what we're doing here, we are bypassing the BMS. The BMS isn't even connected. I'm connected to the minus side, completely minus side, with a 5-volt charger, this time trimmed down to 4.18 by the buck converter, and I'm charging just the first cell. So we are charging by passing the BMS completely with no protection and no defense. This is very dangerous. We need to keep an eye so it will not have too large a voltage. That's why I gave it safe voltage here, using the buck converter. And we are charging in 600 milliamps more or less, and when it drives more or less at this voltage, then we should see that the BMS balances, meaning the moment the BMS is connected, the red LED over this cell should be lit. If it works, then we can discharge it and try another cell, or we can simply try another cell and see that it lit, and then we can discharge everything and do the third cell, which is the best course of action because it's faster. And then once all cells are balanced, we need to continue charging until the cutoff. Okay, let's disconnect the charger. Charger disconnected. And let's see that indeed we are getting a nice bypass over the first cell. So it's very important to make sure that the sequence of colors is the same sequence of color, or we might burn the BMS. See, same sequence. So this is the sequence of the battery. Okay. Now if you watch closely, you see that the first cell is being bypassed. Nice. We have bypass over the first cell. Now we want to see whether we can make the second cell bypass as well. So let's charge the second cell. Now I don't need to connect the minus of the battery to the minus. And after we connect B3 to the minus, which is the previous plus, okay, we can connect the plus to B2 and charge just the second cell. Very dangerous all of this procedure. Need to be very careful not to short them because they could blow up. Okay, and we need to charge. Let's charge. Okay, let's disconnect. Now we are trying to check if both the first cell and the second cell are balancing, meaning they are bypassed because they are overcharged. So what we see here is that only the first cell, only the first cell shows it is bypassed. We will try to pump more charge into the second cell, but if this fails, we'll just have to assume this is a faulty BMS. Okay, let's try again. Now I'm disconnecting. Charger disconnected. As you can see, this is a tad below the limit where it's supposed to give us a cutoff, but still below. So let's see if we get balancing now. If we don't get balancing, well, then this BMS doesn't work. Let's see. Good. So as you can see, I hope, both the first cell is marked as balanced and the second cell is marked as balanced, meaning both of them are being bypassed actively. However, this is marginal because the first cell starts getting balanced in 4.19 volts, the second cell only in 4.20. So basically they will never be exactly balanced. So this BMS is not a very good BMS. The balancing is not very good. So it is within specs. Now what we need to do is discharge it a little bit because we want to check the third cell as well. Notice that a slight current there is here is enough to already discharge it under the balancing limit. So now we'll simply charge the third cell and check if the third cell gets balanced alone without the other two cells. Right, let's disconnect. So we have the third cell and we want to see that this indeed balances. Take it out. Okay. Remember, sequence of the colors has to be the same. Right. The third cell balances also. So we have checked the first, the second, and the third cell, all of them balance. However, the balancing is not exact. So this should be regarded as a BMS which is marginally okay by its specs, but it does balance. Now the most important thing we need to check is something different. What we want to check is, does this BMS cut off if the voltage of one or more of the cells exceeds 4.24 volts? Because in this case it should simply cut off and prevent the cell from overloading until it explodes. That's the most important work a BMS has to do. So does it cut off the current if we overcharge? Now to do this, we need to leave the BMS connected and try to charge it using the main charging, like it was a battery which is being charged, and just see if it cuts the current in the middle of the charge while we're overcharging. Notice that the balance current of the BMS is only 60 milliamps, meaning it could deal with 60 milliamps, but in this case its bypass resistors, which are by the way over here, will not be enough because the current which will be fed will be a lot more than 60 milliamps. So the cells will continue to gather on charge until they will overcharge and the voltage will over voltage above 4.24 volts, and we are supposed to see the BMS cutting the current off. Of course, the voltage which we will read here will be slightly higher because we are reading from the charger side, but still, we are supposed to see the BMS cut off. The cell's supposed to explode not less than 4.4 volts, so we have a lot of time to stop it if it doesn't happen, but the principle of operation is that the BMS needs to cut off the current if the cells or one of the cells get into over voltage seriously. So balancing has been checked, it has been demonstrated nicely in each and every one of the cells. Now the next test is the over voltage test. Okay, let's replace the charger with the laptop charger of 19 volts attached to a buck converter with a heatsink on it, and change the voltage to allow the voltage to give us a stable charging, let's say with 1 or 2 amps even, as long as I have a fan on it. And it should be quite quickly in the point where it's supposed to cut off. So let's see it happens. Okay. Okay, we're already at cutoff. As you can see, suddenly we have 0 current. Now let's say I disconnect the charger. We see a discharge of around 30 milliamps with both the balancing diodes, balancing indicating diodes of the first and the third cell ignited, meaning these are balanced. So basically the second cell is discharging now, and there is discharge current. If I try to charge, then I'm in cutoff. Now, see, initially I have current, but I'm already above the voltage. It should enter cutoff any second now. We let it simply do its job. Here, cutoff. So it does the cutoff. It discharges and it cuts off if the voltage is too high in one of the cells, or in this case 2 of the cells. So alright, this BMS passes the cutoff test with flying colors. Okay, so let's disconnect. It's quite easy because we have this. The only thing which is a little bit more troublesome is the need to use a welder to disconnect here, since I didn't close it using a screw like you should. I simply welded it, but it's quite easy to take it off. Anyhow, what we have here is a tested BMS, and the result of the test are not 100% good. This BMS have a problem. It has a slight issue with its balancing. The balancing is not absolutely heartwarming, and the first cell will start balancing a little lower. However, it's not too bad. I mean, even if we have, let's say, difference between the cells, they can still be regarded as more or less balanced. So this Chinese BMS, very cheap BMS, by the way, it only costs around $2, does the work. It gives us balancing, and it can also give us over voltage protection. As far as I'm concerned, this protection is good enough. So if I just want to check over voltage protection and balancing, this BMS is good enough. Its balancing is not perfect. However, it does give us over voltage protection, and it does it good. So over voltage protection, flying colors. Balancing not so good, but it does balance. And overall, this is a nice BMS, and I will use it in one of my batteries. So as far as I'm concerned, the test has passed. How will I check under voltage? Well, quite simply, I will simply drive my scooter until this will cut. If it doesn't cut, my battery is ruined. If it does cut, then it's okay. I don't even need to open the battery to test it. This is the easiest test to do. So, this was a short clip about how to test the BMS. And as shown, this BMS does balance and does do cutoff. This is perhaps an indicator that it is okay. Now, what I'm planning to do is leave it exactly like it is. I have a bag for it, of course, it will be in a bag, but this is basically ready to technically connect to a battery. So basically, if you test a BMS in these three regards, under voltage, over voltage cutoff, and balancing, and you know that it does it, even if not so good, if the balancing is not that exact, well, then it's worth the $2 it costs. Now you know how to test a BMS using household devices, household tools, using 3 spare cells. And now I can tape this off. There's only one exit that actually needs to be taped off, because the rest is protected, but this one needs to be taped off. so it will not touch anything. Of course, some guy would say, yeah, but if it's the only one, so it can't close the circuit. Correct, but still I'd like it to be taped off. I don't like exposed ends. Alright, so here we have a tool made of 3 spare cells, which can be used to test BMSs. Quite handy, and I'm using it quite a lot. And of course you could say, but why don't just take 3 supplies, power supplies, and change them series and use them? Well, you see, a BMS is a very sensitive device. It has a very sensitive chip. If some kind of, let's say, hopping, even because of a buck converter, gets to it, then this could disturb its work, even destroy it. We don't want that. So if I want to test a BMS, the best way is using a battery. In this case made of 3 cells, because this is in this configuration 3S, but by the way this BMS can be used as 4S or 5S by taking off these 2 resistors here and doing a little bit of change here, and this will make it do 5S even. But this was tested for 3S and it performs okay. The balancing is not 100%, it's not heartwarming, but this BMS should be okay in a battery. Of course, when I do put it in a battery, I will spray some sealant to avoid getting my not so nice welds touch each other and short the cells, which could make everything explode, of course, but I will put some sealant here. Okay, so technically BMS tested. I got to test some more, but this clip was about how to test. So this is extremely rudimentary. BMSs can and do a lot more stuff than just over voltage, under voltage, and balancing. But these are the 3 main functions which most people want from a BMS. So if it costs only $2 and it does these 3 functions, I guess we can live even if it doesn't do the rest. But at least it will protect the cells from over voltage, so it will protect them from starting a fire. Okay, so now you know how to test it. Quite easy. It doesn't require any specialized tools. Only 3 spare cells. Okay, I admit it, I did do some Molex. So you may need some Molex connectors, but that's basically it. Nice.